Welcome to a lesson with Dr. Powell. Let's take a look at solving a trigonometric equation. We're going to do 2 sine of 2 theta minus 3 tangent of theta is equal to 0. Now notice that the inputs into the two trig functions are different. So they represent two different locations on the unit circle if you're thinking about ratios at those particular points, or angles too. An angle of theta and then double that. Two different positions on the unit circle. Now we need to relate it to one position so we can adequately think of this as being an intersection with the unit circle and something with x's and y's. Okay, so what we're going to do is we're going to use an identity here for this part. We're going to change this so it just deals with just sines of thetas and cosines of thetas. Now, and this comes from another video. This comes from, well, one way of thinking about this is just a simple complex multiplication idea. Just remind us of that just briefly. I mean, if we have a point right here, which is cosine theta, sine theta, those are the coordinates as we move angle theta. If we go 2 theta, basically it's the same thing as taking the complex number written right here with the cosine theta plus an I sine theta and just multiplying it to itself, because every time you multiply by a complex number on the unit circle like this, the angles just add together. So if I multiply this to itself, I'm getting the angles theta plus theta, give me 2 theta. Then I'm looking for the sine. The sine is going to be the imaginary part of the result. The imaginary part of the result, so if I think about multiplying those two guys together, plus I sine theta, well, how am I going to get an I out of this? If I just multiply straight down, I'm going to get real stuff. But imaginary stuff comes from crossing. Cosine sine, sine cosine, double that with a coefficient, is going to be the coefficient of I. The coefficient of I is the sine. So of 2 theta, so we can think that's going to be double, that's going to be 2 times sine cosine. But if I'm thinking of the cosine as being x and the sine as being y of something on the unit circle, then essentially it's just x double 2xy. So we can replace sine 2 theta with 2xy, or in other words with the 2 times that, 4xy, minus, think of this tangent theta as being y over x is equal to 0. Now, where we have this equation and this equation, right? We just want to find out the coordinates x, y that make both of these work. The intersection with this curve with the unit circle right here is what we're looking at. And then just the angles that take us to those particular intersection points. So right here, we can add fractions here, multiply this guy by x over x, so common denominator. So we end up having 4x squared y minus 3y over x is equal to 0. A fraction is equal to 0 when the numerator is 0, assuming the denominator won't be 0, so x not equal to 0. All right, so this will give us just the numerator, and the numerator factors. 4x squared minus 3 times y is equal to 0. This multiplication is equal to 0 if and only if y is 0, or 4x squared minus 3 is 0. Okay, so we basically have our places on your circle that will give us anything that gives us a y value of 0. So y value of 0 on the unit circle, that would give you right there and there. And notice that neither of those points make x 0, so we're in business there. And so that would be an angle, at least from 0 to 2 pi, that would be an angle of 0 and an angle of pi if we're in radians. So 0 and pi are basically just, if we're going to think about any angle, it's just multiples of pi. So pi k come from this guy, all right? Or when the sine theta is, which is equal to y, when that's going to be equal to 0. And it's going to happen when theta is equal to any multiple of pi k. So that would, or any multiple of pi, where k is a integer, a whole number. Okay, positive or negative. Now, right here, when is this equal to 0? Set it equal to 0 and solve. You're going to get 4x squared is equal to 3. In other words, x squared is going to be equal to 3/4. So x is going to be equal to plus or minus square root of 3 over 2. So the cosine is going to be equal to that. So we think x value is going to be square root of 3 over 2. So that's kind of like the bigger of our special angles, and either negative or positive. So that's like 4 points. Okay, but any one of those 4 points would give us what we wanted, will give us that 0 there. And notice that in our original equation, both tangent and sine will be defined nicely at those points, so we're okay for this particular angle. Well, actually, you have to be careful with the double angle, but essentially looking at this, it pretty much tells us what we need to avoid. We just want to avoid x being 0 or 0. So right here, looking at those particular locations, for the what angles would that be? So it's the one further over here. So that would be the smaller of the angles as we're going down. So pi 6 right here. So basically pi 6, negative pi 6, or kind of, or just the reflection of those over here. So pi 6 shy of pi. So 5 pi 6. So we have, in fact, in this quadrant, we could think pi 6 and 5 pi 6. So pi 6, and we also have 5 pi 6. And then you notice, actually, we could just do a negative pi 6 there. And negative of this angle, if I go all the way to here, the negative going all the way to there is actually just going to there. So really I have, maybe I just do a plus minus, right, on these. And then essentially every 2 pi it'll repeat itself. So I could just say plus 2 pi k, plus 2 pi k. And I guess if we're clever enough, we realize that negative pi 6 and 5 pi 6 are pi away. And let's see, plus pi 6 and negative 5 pi 6 are pi away. So you could simplify this a little bit, or write it in a different form, but I'm just going to keep it like that for now. Okay, so these are the different angles of theta that actually solve the equation. Thanks for watching.